Hello everyone, welcome to IP Study video lectures. Today we will discuss grade 8 science chapter exploring forces. In this chapter we will discuss about force. Force is due to an interaction, types of forces, weight and its measurement, floating and sinking. In previous grades as well, we have discussed about forces. So, whenever we are talking about force, force is a pull or push. So, what do we need to pull or push an object? We need to make an interaction. So, what we can do using force? We can make an interaction and push the object or pull the object. We can change their directions, we can change the speed of any object and the state of motion of any object. Let's discuss this in detail. So, how can we check that force is applied on any object? To observe this, what we can do? First, we can make an interaction with an object and then try to push or pull. How we will know that the force is applied during this action? The object will change its position. For example, if you push a bag which is kept on a table, so what will happen? The bag will be moved away from its original position. So what is happening during this action? The position of the object is moved due to a push, which means due to a force. Similarly, you can open the door by pulling the handle. You can pull the lever in the handle and open the door or close the door. So, in both the actions, we are changing the position of the object. While pulling and pushing the door as well, we are changing the position of the door. In this activity, we can find out in which direction the force is applied. For example, when you are pushing the bag away, the direction of the force is away from you. If you are pulling the door towards you, the direction of the force is towards you. So, force is always applied in a certain direction. We can conclude here. Whenever a force is applied, there are some effects which we can see as a result. What are these? The object on which the force is applied, it can change its state of motion. Means if the object is stationary, it is not moving, it is in rest. After applying the force, it will start moving. Stop a moving object means again the change of the state of motion. If an object is already in motion, by applying the force, we can bring it to the rest. Means we can change its state of motion from movement to resting state. Change the speed of moving object. By pulling the brakes, we can slow down a vehicle, or by kicking a ball which is coming towards you at a very high speed, you can first reduce its speed. Also, you can direct it into different path, means you can change its direction. So, next effect is changing the direction. When you ride a bicycle, you pedal your cycle, you increase the speed, and as soon as you turn the handle, the bicycle changes its direction, means the movement is now happening in the other direction. So, we can conclude force is used here to change the direction of the motion and change the shape or size of an object. For example, when you play with the dough, so what do? You apply some force using your hand and you change its shape and size. When you are cutting any object, you are applying force using a knife on that object and cutting this into pieces, means you are changing the shape and size of the object here again. To observe the effect of forces, you can conduct various activities and you can find out which of the effect of force is visible in that activity. For example, gently push a ball resting on the floor. So, state of motion is now changing from rest to motion. Roll a ball towards a wall or catch it. When you are catching a ball, means the ball is already in motion towards you and you are trying to stop the ball. Ask a friend to gently push your moving cycle. So, in that case, you are already paddling your cycle, means you are applying force, and when your friend is pushing you or your friend is applying force on your bicycle, the speed of the bicycle is now increasing. So, that's how you can test different effects of forces by conducting various actions here. Force is always due to an interaction. That interaction can be between two objects. One can be living or non-living, or both can be living or non-living. An interaction between an object and a field or induced due to the force. For example, pushing a book. In this case, when you are pushing the book, you are living thing and book is non-living thing. So, you are making an interaction with the non-living thing and then applying the force. So, interaction is between one living and one non-living thing. Pulling a wagon. If a wagon is connected to an engine, in that case both objects are non-living and interaction is made between two non-living objects and one is applying force on the other to change its position. Magnetic attraction. Magnetic attraction occurs when two magnetic fields interact with each other. Gravitational pull. This force is applied when an object interacts with a gravitational field, means an area where gravitational pull is applicable. So, that's how we can conclude that all the types of forces comes in action when two different objects or two different fields interact with each other. Resultant force. What is resultant force? Is it like that every time when we are talking about the interaction of a force, only one force is applied? No, there can be multiple forces applied on one object during one action. For example, when you are pushing a box, so gravitational force is applied on that box due to its weight. At the same time, you are applying muscular force on that object. So, two forces from different directions are applied on that box. Two different forces from the same direction also can be applied on an object, which means the forces can be applied from the same directions or from different directions. When these forces are applied on any object, means multiple forces are applied. So, we calculate the resultant force which enables the change of the position of that object, or it will not change the position of the object. Let's understand these interactions here. For example, when you and your friend both are pushing a box from different direction, means applying the force from different directions. If both are applying same amount of force, means the magnitude of the force is same, the strength of the force is equal, in that case the resultant force will be 0, because the resultant force is equals to force 1 minus force 2. So, if F1 is equals to F2, then the result will be 0, means the box will not move at all. If one of the person is applying greater force than the other one, in that case what will happen? Suppose F1 is greater than F2. In this case, we will have some magnitude of the resultant force, and as a result the box will move in one direction. What will be that direction? If we say the boy is applying greater force than this girl, so what will happen? The box will move towards the girl because the force applied by the boy is greater, it's more. If both of them are applying force from the same direction, This is F1, F2 applied from the same direction. Doesn't matter what is the magnitude of the force. Maybe both are applying the equal force or different magnitude of force. In such case, the magnitude of the net force, or we can say it will be in the direction of the applied force. So that's how if multiple forces are applied on any object, we can find out the resultant force and then we can conclude whether the object will move or not, whether the object will change its position or not. So if the resultant force is 0, the object will not show any movement. Types of forces. What are the types of forces? There are two major categories of forces. One is contact and second is non-contact force. Contact force means the object should be in direct contact with each other, absolute contact with each other. And in non-contact force, it's not necessary that both the objects or both the field are in direct contact with each other. For example, muscular force and frictional force. To drag the box or to push the box, you need to touch the box first. Means you are making a direct contact with the box. Your muscles are in direct contact with the box. That's why we call it muscular force is a contact force. During frictional force, two surfaces must be in contact with each other, whether the surface is rough or smooth. In that case only the frictional force will be generated, and we can say the frictional force is also a contact force. What about the non-contact forces? As I said earlier, in non-contact force, two objects or field must not be in the direct contact with each other, which means during magnetic force, electrostatic force and gravitational force, the object is interacting with the field of that force, not directly to any other object. Let's check the contact force in action. Muscular force, when you are lifting a object, when you are pulling any object, dragging any object or just holding any object, you are using muscular force. If I am holding this pen, it means I am using muscular force through my fingers to hold this pen in this position. If I am carrying a bag on my shoulders, in that case the straps of the bags are in direct contact with my muscles, with my body, and then I am applying the muscular force to lift that weight of that bag so that I can move it from one position to the other position. What about the frictional force? When two surfaces comes in contact, one surface or both the surface can be rough or smooth. So we can say the frictional force is dependent on the irregularities between the two surfaces. If there are irregularities due to the roughness of the surface, so what will happen? These irregularities will try to interlock with each other and will try to stop the motion. Like if there are two surfaces with irregular or uneven texture on the surface. So the irregularities will interlock with each other, and when you rub these against each other, these will interrupt the motion. These will try to stop the motion. In this case, the opposing force which is trying to stop the motion is called the frictional force. If one of the surface is smooth and the other one is rough, less frictional force will be present there. If two surfaces are rough and interacting with each other, to move them against each other, more frictional force will be experienced. Means you need to apply more muscular force to rub these two rough surfaces against each other so that you can overcome the frictional force. So here we can conclude that frictional force is an opposing force which acts in the opposite direction of the motion to try to stop the motion. Now check the non-contact force. Non-contact force doesn't need any direct interaction of two objects. First example is magnetic force. How can you test this? Like fix one stick using any tape or glue on any surface and take two disc shaped or ring shaped magnets. Place one magnet in this stick, like insert it over the stick and it will settle at the bottom due to the gravitational force. Now take another ring magnet and repeat the process. If both the magnets stack over each other, which means the surfaces which are interacting with each other have different poles. We already know, we already have studied in previous classes that magnets have south pole and north pole, and like poles repel each other but unlike pole attract each other. So if the surface, the bottom of this disc and the top of this disc have opposite poles, means if it is north and this is south, they will stack over each other. If these are same poles, like poles, suppose both are north pole, so what will happen? These two will interact with their magnetic field and they will repel each other, because like poles always repel each other, push away each other. So what is happening here? Both the magnets don't need to touch each other, do not need any direct interaction here, but still they can behave depending on their nature or magnetic property, and they start hovering or they start repelling each other. Okay, so what we are concluding here? We are concluding that magnetic force is a non-contact force which can be applied, which can be experienced from a certain distance when we are seeing this gap between these two magnets, and if both the surfaces which are interacting with each other have same poles, they will repel each other. If these have different poles, then they will attract each other from a certain distance even. Next is electrostatic force. So electrostatic force is produced when the surfaces are rubbed, then charges are produced on these surfaces, and these charges either attract different fields or repel different fields. So when certain materials are rubbed together, they build up static electricity, they build up static charge, but this charge doesn't move like the electric charge in any other conducting material. So we call it static charge, and due to this charge, object either repel or attract each other from a certain distance without coming in direct contact. So we call it non-contact electrostatic force. How can we test this? Take a paper, tear it into small bits and leave it over a surface. And now take a plastic ruler. Rub the plastic ruler with a woolen cloth or with your hair. In such case, the plastic will gain some charge. And when you will bring this charged scale closer to the bits of paper, it will start attracting the bits of paper from a certain distance without coming in direct contact with the pieces of papers. Can we produce a desirable charge on any object or desirable electrostatic charge like the positive charge or negative charge? Yes, it is possible. For that, we can select the type of material. For example, if any glass rod or if any balloon, rubber balloon is rubbed with woolen cloth, in that case negative charge is produced over the balloon. If this is rubbed with silk cloth, the negative charge will be produced. So there is a series of material which produces positive or negative charges on the object. So we can induce a charge as we desire on different objects. Do these charges repel or attract each other like the magnetic force? Yes, these forces also show repulsion and attraction. These charges also show repulsion and attraction like the magnetic force. Next is gravitational force. We know every object in our atmosphere experiences gravitational force towards the center of the earth. How can you test this? Just flip a coin in the air. Where will this coin go? It will come back to the ground surface. Why? Because the gravitational pull of the earth attracts every object towards the center of the earth. So what happens when you throw any object or like a ball in the atmosphere? So it goes with the speed, and at a certain height it stops and starts falling back due to the gravitational pull and comes back to the surface of the earth. What is weight and how do we measure it? So when we say weight, weight is the amount of particle of any object which is packed there in that object, and they experience the gravitational force on them. That's why they start falling on the surface. But as it is the force applied on the particles of that object, we also conclude that the weight is a kind of force acting on that object due to gravitational pull. So if we are calculating the weight, we are calculating a kind of force. As the unit of force is Newton, we will calculate the weight as well in Newton. So what do we conclude, or what do we calculate in the grams and kilograms? We are calculating the mass, the amount of particles enclosed in any object. Next is floating and sinking. So what do we understand about floating and sinking? When you place any object in water or in a bucket filled with water, what do you see? Either it will move to the bottom of the water or bottom of the bucket, or it will rest over the surface of the water. How do we decide which object will sink or which will float? This depends on the density of an object. This floating and sinking also can be understood using one experiment here. When you take a bottle and try to immerse it, try to push it in the water filled in a bucket, you experience some force on your hand. That force is due to the water particles. There is a force applied by the water particle which is always in the upward direction. This is called upthrust or Buoyant force. It is also called buoyancy or buoyant force. So as soon as you start pulling the water bottle upward, you feel less force applied on your hand, because that buoyant force is already pushing you upward and you are not working against that force. So in this case, what happens? As soon as you go deeper in the column of a liquid, you experience more buoyant force or more upthrust. Also, it is dependent on the weight of the object. The heavier object experience more upthrust. So in this chapter, we discussed about the force, the interaction of the force, what are the conditions for a force to come in actions, like there should be some interaction of the field or object or to object directly. We also discuss about the effects of forces, what kind of changes a force can cause. Also, we classified the forces into contact forces and non-contact forces depending on the interaction between two objects and a field and the object, or two different fields. We also learned that electrostatic force and magnetic force can be attractive force, also can be repulsive force. And we can measure the weight of the water displaced by any object to find out whether the object will be sinking or floating on the surface of the water. That's it for the day. We will see you with the next topic. Thank you.